Okay, so we're just getting started here. So we have Unit 2, Lesson 5. So we're just kind of just over the halfway point of this unit. Okay, now we're going to start turning to more some solving. And we're going to do that with factoring. So we're still doing the same stuff. It's not completely new, which is good. Okay, and remember what I kind of told you, and I do this a lot, and if I overwhelm you, I'm sorry, but we solve by factoring to help us figure out intersection points. That's the main goal of what we are doing. Remember how I told you if you factored x plus 3, x minus 5, for example, with our factor, that tells you where your parabola crosses the 0, where it crosses the x-axis. That's what it does for you. Okay? And so what we're going to learn today is what number makes a positive 3, 0? What number makes a positive 3, 0 when you put them together? What's the opposite of positive 3? Negative 3. And then what's the opposite of negative 5? Positive 5. So this picture, right now, if I put this in my TI-83 calculator, my parabola is going to cross at negative 3 and 5. And it's going to be, we'll talk about that stuff later. But that's what it does for us. It tells you where your parabola crosses. Okay, I'm throwing stuff at you. But what I just told you, the 0 property, we just did. Okay, this is today's lesson. You being able to do that. Okay, so that's what we're going at. Okay, so investigate the 0 property law. So what it tells you is the statement. I swear these must be like ingrained in my head because I didn't even look at this, but I picked a 3. Like I had to do them on accident. It's the same one. Okay, so the statement x minus 3 equals 0 is true only if x is what? Positive 3. Because 3 minus 3 is 0. Okay, the statement x plus 1 is 0 only when x is negative 1. The opposite. What makes this go away? A negative 1. Negative 1 plus 1 is 0. 3 minus 3 is 0. That's what we're trying to do. You're making a 0. Okay? And so the statement, x minus 3 times x plus 1 is 0 if either x is 3 or negative 1. So you have two answers. Just like right here, we had two answers. We had two crossing points. Okay? And this is a good one here. Okay, well, let's do the easy one. What's the opposite of positive 1? Negative 1. Or, what does that have to be? If it's out there by itself, and it's not adding or minusing to anything, what was the tie? 0. It needs to be a 0. So remember that. Whenever you have an x out by itself, the only way it can be 0 is if it's 0. Okay? That's the only way you can make it a 0. Okay? So just for, again, I'm a visual person sometimes. What would that look like parabola-wise? We'll say this is negative 1. That's 0.
Jim, your class changed.
It'd cross like this. You go through negative 1 and going to go through 0. I kind of missed it, but you get the idea. Okay, moving along. Okay, so the 0 product law, last two statements in the investigation are examples of the 0 product law. So what we did is the 0 product law. Okay, we always want to figure out what makes A 0 and what makes B 0. Okay, because if we have two binomials, if we get the left one to be 0, then what happens to the right one? 0 times anything is 0. So the whole thing's 0. If I get the right side to be 0, then it makes the left side 0 no matter what. Okay, that's why the 0 product law works for either binomial. That's why you have two answers. Does that make sense? So we need this to be 0 or B to be 0. Okay. Let's see if I'm going to get ahead of myself here, but some of you guys are thinking, so take advantage of it. What are the possible answers, or how many different numbers, okay, wait, let's see. How many different ways can a parabola cross the x-axis in terms of numbers? We've talked about it can cross twice. What other numbers do you think it could be? It can't cross 3 times. It can't cross 4 times. No, it can't cross. No, go the other way. 1. You can't cross anything negative. Okay? I like your heads out, though. You're getting the math numbers out there. It can cross once or it can cross none. Okay? So just, again, I'm going a little bit ahead of the game here for you, but there's only 3 types of parabolas you can have. You can have one that goes through and crosses twice, what we've been talking about. We can have one that goes through once, and what that means is it bounces. It hits it once and bounces off. Or you can have something that's up here that never crosses. Okay, so 2, 1, or 0. We'll talk about how to find those later. Advanced question, does anyone want to take a guess to how you get a bouncer? We have factored these. The what? The same number. What creates the same number? What type of factor? Yeah. Perfect square factor. So like if I had an x plus 2 times an x plus 2, which would be x plus 2 squared. That's a bouncer at where? For that one I just did. No, opposite. Negative 2. So this guy would bounce right here 1 time. That's what a bouncing one would do. Does that make sense, kind of? Again, that's just kind of giving you stuff early. I just sprinkle in stuff as we go, because then when I teach that, you won't be completely foreign to it. All right, so let's keep going here. So complete the following, solving for x in each equation. So this one, if I solve for x, I divide by 8. X is still 0. So this is proving that when the x is outside, it's 0 is the only thing it can be. Okay? Here we go, this one. We would like to go, okay, so this would be x plus 2 equals 0, x minus 7 equals 0. So this one's x equals negative 2, and x equals positive 7. Just using the 0 property, again, it's just opposite. So, this one, how many x's are there? 3. So how many times is that parabola potentially going to cross the x-axis? Well, it's a cube now. So 2 is for a square. 3. Potential. What's that? It can't cross 3, but what were we talking about before? We were talking about squares. This one's a cube. Dang, those little tricky math things. Yeah, no, it's a cube, and we're not going to do a cube a ton, Kyle, so this one's the more what you need to focus on. Okay, but cubes, you do need the idea. Remember, I told you cubes look like this. They're like little ends. So you see what happens is it's going up, down, up. 3 changes of direction. Does that make sense? Let me try to do it in color here. Up, down, up. Okay, so there's 3 sections because it's a cube. Your parabola, down, up. 2 sections because it's a square. Okay, now potentially they both could not cross the x-axis at all. This actually has to, but this potentially can't at all. This could only cross once. It just depends on where it's at in the picture, but you get the idea. The point is there's 3 x's, there's 3 possible. Okay, so for this one, the zeros, x equals 0, negative 2, positive 7. Okay, now D is a good one to have on there because when you see those ones, it's not going to be negative 1. Why is it not negative 1? Stay with me. Don't sleep. I know it's hot in here. It makes you get tired. Huh? Yeah, because the 2. The 2 is not just an x. Because if I just put a negative 1 in here, what's 2 times negative 1? Negative 2. What's negative 2 plus 1? Not 0. Right? It's not 0. Yeah, it's negative 1. So watch. All you have to do is, and you'll get used to this where you won't have to do this every time, but it's just 2x plus 1 equals 0. Minus the 1, divide the 2. This one is negative 1/2. Wow. Negative 1/2 is that first 0. Okay, all I have to do, if you don't see it right away, just set what's inside equal to 0 and solve for x. Minus the 1, divide the 2. So here, I won't do it out. Add the 2, divide the 3. So if I add 2, divide by 3, what do I get? 2/3. Okay. How are we feeling? Are we okay? All right, let's keep on going here. Okay, why is it acceptable to divide by 8 first in A and B? Because it just makes it 0. Why is it not acceptable to divide by x in the first term in C? What was it saying? Because you can't divide by a variable when you're solving. So these questions, they're not really beneficial. You get the idea. We're just looking for the opposites. Okay. All the above equations of polynomials, one side of the expression, other side equals 0. Okay. All right. So now we're just going to get right here to solving. So complete the solution of the equation for x squared minus 9x plus 20. So first off, let's just stay with our basics. What's our method of factoring this? What's it called? Inspection, right? Our a is 1, so we're doing inspection. Factors of 20 that add up to negative 9. Negative 5, negative 4. Good. So minus 5, minus 4. Okay, so we have two answers because they're different. X minus 5 or x minus 4. What makes this one 0? A positive 5. What makes this one 0? A positive 4. The opposite. Okay, so your solutions are 4 and 5, or 4, comma 5. You can write it as 1 like that. Either way is fine. All right. Okay. Now let's actually get to some here. So these ones are all forms of what you think, because they're all with two terms. So then what are you looking for? Difference of squares, right? If you see two terms only and no middle, you should immediately be thinking difference of squares. This one and this one are obvious. This one and this one need some work, because 90 is not a perfect square. Okay? So here, hopefully this one's easy for you, is x plus 9, x minus 9. Okay? Difference of squares. Square root of 81 is 9. What makes a positive 9 0? Negative 9. What makes a negative 9 0? Positive 9. Okay? Good. Go on to the next one. Is 4 a perfect square? And is 9? Yep, so then we're good. 2x plus 3, 2x minus 3. Now this one takes a little bit of work because it's not an automatic plus or minus 3 because of the 2 in front. So this one I minus the 3, divide the 2. So the first one, minus 3, divide 2, so negative 3 halves. The second one, add 3, divide by 2. Negative 3 halves, positive 3 halves. Okay. What do you think, Kyle? What do I have to do on C, you think? Like, what to get? We're thinking difference of squares, but it's not ready yet. So what would you do? Good. Take a 10x out. Yeah, a lot of people miss the x. 10x comes out. That gives me x minus 9. Now, is this a difference of squares? No, because that's not squared anymore. This is done. Okay, this one's done. So I have two x's, so I'm going to have two answers. What's this one going to be? Awesome, 0. Everybody forgets that. X is 0. Has to be. When it's pulled out by itself, he has to be 0. This one right here is going to be 9. Good. Okay, Adam, what do you want to do on D? What would you pull out on D? Okay, so you take... No, you're fine. You said 10, right? And then we can't take an x out because they both don't have an x. So just the 10. So that gives me x squared minus 9. Now we have a what? Difference of squares. So now we're going to break that down one more time. Yep. Okay. Concept question. This 10 right here, does that give me any answers? Why, Sarah? Right, because your last thing you said, so I was looking for it. There's no x on it. This does not mean anything in terms of an answer. Okay? This means something in terms of your parabola, but that's for another day. Okay, so our answer in this is just where the x's are. Negative 3, positive 3. That's it. The 10 is not really part of the answer. Okay, because it does not have an x. All right, a couple more here, and then we've got some little bit of applied ones, or story problems, if you will. Okay. All right, so looking at this one, do they have a GCF I can pull out? Do you see a GCF? No. So then, where am I at in my tree, my flow chart? What am I going to be doing in terms of my method? Decomp. Yep, so we have to decomp. Okay, and then James, how do I start decomp? 3 times negative 10, so I have negative 30. I want negative 30 to give me a negative 13. Be careful, though. Do you know it? Good. 15 and 2. A lot of people think it's a 10 and a 3 again. Okay, it's 15 and 2 because it has to be difference. So it's a negative 15 plus 2. Okay, this is where we break the middle up. So I'm going to go 3x squared. Let's go minus 15x here, plus 2x here, minus 10 here. And then we're going to group. All right, Tom, what am I going to pull out of the first piece? 3x. Okay. That gives me x minus 5. Okay, and Davin, I'm going to pull out the second piece. 2. Okay, we're happy. Those match. So now I have 3x plus 2 times x minus 5. Okay, well, this one, that one's easy. What's that one's answer? 5. What's this one going to be? Minus the 2, divide the 3, so negative 2/3. 5 and negative 2/3 is your answer. All right. Logan, what's bothering you with part B? There's no 0, so what would you? We need to get a 0, right? How would you get a 0? Don't want to divide by the 5 yet. We want to get one side 0 before we pull some stuff out. This guy's messing us up. What makes us think? Yeah, we just want to move him over. Okay, we just want to say add 25, add 25. That's all I want to do. We can do that. Remember, you can do anything. Golden rule of algebra. You can do anything to one side as long as you do it to the what? The other side. So that's gone. 5x squared plus 30x plus 25. Then what Logan, you guys are saying was we can take the 5 out. That's true. Now we're at this. Now it makes it easy because it's just an easy inspection. Factors of 5 to add to 6. The 5 and 1. Okay, and Zach, what are our answers then? Good man, good. Okay, and again, don't forget, that's where the parabola crosses the x-axis. Don't forget that small point. All right, last page here. Okay, so this is kind of steps for when you're doing word problems, okay? So this is kind of a good procedure. I know a lot of you probably won't refer to it, but I would strongly encourage you to when you get lost in a problem. So first thing, introduce a variable that represents the unknown value, so your x, okay? Form a quadratic equation from the given information. Solve the quadratic equation using the methods in this lesson, and then state the solutions or state the zeros. Okay, so with that, let's look at this one and follow those procedures. All right, so it says an area of a rectangular sheet of paper is 300 centimeters. And how I always do my problems is, we'll take advantage of the highlighter thing here, I always kind of underline my numbers. The length is 5 more, gotta get all of that, then the width. Form a polynomial equation and solve it to determine the perimeter of the rectangular sheet. So I'm trying to get the perimeter from the area. Okay, so who can translate this into what this means? So first off, let's just make sure we remember length times width equals area. Right? We know the area is 300. How can I write this from what they gave me? How can I write this from what they gave me? The length is 5 centimeters more than the width. Yeah. Exactly. X times x plus 5. They're related to each other. They did it on purpose so that you'd have one variable. Okay? So the length is 5 centimeters more than the width. So the width, what we don't know. The width is your x. And the length is x plus 5 because it's 5 more for the length. Does that make sense? So my width is right here, just so you're staying with me. And then my length is right there by the information they gave me. Okay, so now, this kind of goes back to Logan's question here. With this problem, we always want one side to equal what? 0. So what am I going to do with the 300? Subtract it over. So I'm going to distribute this first. So I'm going to get x squared plus 5x and then minus 300 because we're going to minus the 300 over so we can get 0. Now we're going to try to factor that by inspection. So everybody know the factors of 300 that are 5 apart? Yeah, you got Tom. 20 and what? 20 and 15. Good. So 20 and 15. That's a positive, so that's a positive, so minus. So your factor is x plus 20, x minus 15. Okay? Now this is where it gets a little bit tricky, but we have to use common sense. This means, okay, that my x is, what is our value for x? Like, what does it represent by what I labeled right here? Width. Good. So my possible answers are x can be negative 20 or x can be positive 15. Which one of these should you reject? The negative 20. We cannot have a negative 20x. Okay, your length can't be negative 20, so your x is 15. That's your width. Okay? What's your length then if the length is 5 more? 20, and that's kind of where it comes from. Okay? It's pretty much telling you what your other answer is going to be. So our rectangle is a 15 by 20 rectangle. It wants the perimeter. So we want 2 times this, 30. 2 times this, 40. Our perimeter is 70. So you have 2 widths and 2 lengths. I went too fast. I'm sorry. Rectangle, right? Any questions there? Last problem. I know you're down on me. It's hot. I understand. I guess it's better than snow for right now. I don't know. All right. Diagram shows a cross-section of water trough whose sloping sides AD and BC make an angle of 45 degrees with the horizontal. The length of DC is 36. Okay. Show the area of the cross-section is x times 36 minus x centimeters squared. Okay, so you kind of have to, if this is 45 degrees, you guys did your triangle stuff a little bit, I think, in Math 10. If that's 45 degrees in trigonometry and that's 90, what's this have to be? 45, right? And then same thing here. And a 45-45 triangle, what do you know about the legs? They're equal. Good. So if this is x, then this is x. If this is x, then this is x. I'm talking about this piece here. Does that make sense? Okay. And then so what we do is, to label this one, we say this piece is 36 minus the 2 x's. That's where they got the 36 minus x. And I'll show you in a second. Okay, and they say, yeah. Okay. So, what are they going to do here? I think it was just a misprint last time. Oh, yeah, the 1/2. Okay. Okay. 36 cross section. I want to make sure I find the middle of the outside. Oh, each one. Okay. Okay, gotcha. So I'm finding the area of all 3 of them. Sorry, so we'll call this one 1, this one 2, and this one 3. Okay, 1 and 3 we expect to be the same. So area 1 is going to be what's area of a triangle's formula? Base times height divided by 2. So x times x over 2. So x squared over 2 is area 1. We can go ahead and just copy that for area 3 as well. Okay, and then area 2 is going to be, that's a rectangle, so length times width, 36 minus 2x times x. So that's going to give me 36x minus 2x squared. And what we're going to do is we're going to add all these. So x squared over 2 is the same thing as what? Like it's the same thing as half an x squared. 1/2 x squared. So what's 1/2 plus 1/2? 1. What's that? I'm trying to say that if I add these two, because I'm adding all the cross sections, x squared over 2 plus x squared over 2 is just x squared. That's what I was trying to say. Okay, and so now I'm going to add that. What's x squared minus 2x squared? So I'm combining like terms. What's 1 minus 2? 1 minus 2. Stay with me. Last one. Negative 1. So I have 36 minus x squared now. Okay, and, excuse me, so 36x. So you pull the x out. And we have what they asked me. Which one? This guy? He was already there. I just forgot to write him over here. I just forgot to write it. So this guy turned into 36x because this x distributed. So 36x, 2x squared. Okay. Then when I rewrote that here, I forgot to put the x. So I mean, it didn't disappear. I just forgot to write it. Okay. And then so then it was still needing to be right here. Is that the x we're talking about? Anything else on that? Okay, I'm going to stop talking for now. If you want to try the last one, have me check it, I will. Okay, it's just you kind of you finish the problem off. Okay? All right.